Creator dashboard. Hold on. We're almost there. We're almost there. Copy. Game development. Okay. Okay. That's updated. Sweet. So now we go to channel. And then we mute. And then we lower quality. And then we, nope, minimize. We go to Discord. We paste. Nope. We copy, then we paste. Enter. I'm buying new stuff tonight to set up another monitor. This is getting crazy. Okay. Okay, then we go to YouTube. Then we find my stream. Then we mute it. Copy. Then we lower quality. Then we find music. We're doing Hololive stuff, right? What's like a good... Is there like Flare original songs? Yeah, these are covers though. Ugh. Why not? It's Deco 27, that's fair. That audio is probably fine. Little vibes, but you can barely hear it. Okay. Okay, okay. Hi everyone, welcome. The book of shaders.com. Where's the test? They have like a test suite where you can do all this stuff online. Hold on. Shaders online. Shader toy, not shader toy. Book of shaders edit. There we go. Oh, there it is. Okay. This is good. This is what I want. All right. Now we're going to grab this. We're going to move it over here. Shrink this down so I can see chat since I'm on one monitor. Yes, 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 Code Toil. Okay, don't give me sass, all right? Streaming's hard with one screen. All right, let's make some shaders. So, how do I describe shaders to people who have no idea what I'm about to do? Okay, what is a shader? Oh God, there's so much we have to talk about. Do I want to teach you how to do shaders, or are we doing this shit like live? We gotta do it live, right? Do I have time to explain how a shader works? Okay. When you... Hold on, how in depth do we want to go? Everyone knows what a shader is, right? It's when your GPU uses what we call hardware acceleration, meaning you're using your GPU, not your CPU. You can render a lot of information very quickly. And that's basically what GPUs are for. And what we're concerned about 99% of the time right now is color. So basically everything, oh gosh, what's the basics here? Okay, so this main, right? This is a shader file. When we go into our C++ program, not today, but we will, we're gonna have a bunch of these shader files that we will then organize in like a shader class, right? That'll just handle all the storage and everything. Basically, what will happen is this main function, its job more than anything else is to return this frag color. This is, I think it's called pixel shading, not vertex shading, because we're not doing like cubes. We're not doing 3D objects. We're not shading vertexes, we're shading pixels. Different purposes, they each have a place. For our purposes, because this is effectively a 2D game, we're just doing it in a 3D environment. Well, that's not true. We're building it with shaders. It's a 2D game with shaders, but it's gonna give the illusion of 3D. It's basically, we're not gonna have a 3D engine. We're just using shaders, that's all, right? So that's why we're doing this frag color thing. Basically, these frag colors, this call to main just returns a color. That's really all it does. It's void, but it's gonna end with a frag color. That's why you have these colors shifting right now. It's because you have this color here that this turns into, this vec4. this color is just a vec 3, right? Yeah, vec 3, meaning a color, oh God, RGBA, red, green, blue, alpha, right? That is a vec 4. A vec 3 in this case only has 3 of those 4 pieces of information. The 4 here, this vec 4, this 1.0, that's the alpha channel. So if I make this 0.0, watch what happens to the color. It's black because it's still running, it's still shifting, and we'll talk about why it's shifting in a second. But this 0.0 to 1.0, that is the scale we're working at, where 0, if we were talking about like speed, 0 is standing still, and 1.0 is the speed of light. That's the kind of scale we're working at. Why is there a fly in my room? So just keep that in mind, where if you go like 2.0, nothing changes between 1.0 because it caps at 1.0. So that's what we're talking about here. Anyway, the reason why this is shifting is because we have this color value, right? This vector 3. So this is your red, this is your green, and your blue is the absolute value of the sine of u time. Now that means like it's an arc, it's shifting, right? So instead of time, sine, I go cosine, it's different. Or if I go tangent, it's a different kind of arc. You see how it's like kind of doing some weird stuff? What if we go like atan, right? Atan, oh, atan wouldn't shift, right? Because it's absolute value, huh? The reason why it's absolute value is because if we're like charting a graph, let me kind of show that in paint here. Bloop. I see your message there, 1 second. So if we have like a chart here, right? And, boop, hold on. I hate how thin that is. Brushes. Thick. Okay. So you have like this, your XY, right? Your Y, your X, and then your sine, you know, you have your sine, your cosine, your tangent, all that stuff, right? I forget how the exact math works, but in any case, all sine is an arc. Cosine is a different kind of arc. A tangent, I think it goes like that. I think that's logic there. Anyway, that's what this absolute value is right here. That's why they call it, because absolute value of, I think a sine goes through the vertex. I think that's sine. So an absolute value of a sine is this, or it could be, this. I forget which one's which. I'm not great at trigonometry. But anyway, that's why you call absolute value. So watch what happens when I remove this absolute value, and you'll see what I'm saying. It's the exact same colors, but look how slow it shifts. So right now it's in negative space, positive space, negative space. So when you go absolute value, then it'll do that. It'll shift more consistently. Anyway, used to project from 3D meshes to the 2D grid and to assign a color to every pixel. Correct. All right, all that is to say, what we're gonna do now, all I want to do right now, just to make sure I get comfortable with shaders, because it's been a while since I really got into it. We're gonna make a shader now that's gonna be our mouse. We're gonna keep it super simple. What I'm imagining in my head, actually, let me bring up paint again to show you what I want to draw here. What I'm imagining in my head is I just have like a stamp or something, circle. Okay, what I'm imagining is that I want like, yeah, that's maybe not that big, but solid color, black, please. Fill with black, please. There we go. And then have maybe have a white outline. I don't know yet. Probably not right now. But anyway, that's gonna be like our mouse, right? So we're not gonna see our mouse. It's just gonna be there following the mouse the whole time, right? Kind of like how this black dot is on paint right now, but bigger. It's that kind of idea. But we're gonna do something to give it a little bit of animation. What we're gonna do is when we move the mouse up, it's gonna like stretch it like that, right? And then it'll squish back to normal very quickly. So we move it to the right, it'll like stretch it like that, and then it'll go back to like normal, and we'll kind of smooth our way between them. That's what I'm imagining in my head. Sine x almost equals x near x equals 0, and cosine x almost equals 1. Well, there you go. That's why I don't know trigonometry that well. In any case, that's what we're going to work on today. We're just going to have this little mouse. It'll go around the screen. It'll be beautiful. So, we're not going to care about time. We are going to care about mouse. Right? We don't care about time, right? No, we do care about time. Because time is how you account for, although maybe we can just do it logically. We're like, if mouse is distance away from end, whatever. We'll keep it for now. All right, so vec2 st equals flag coordinate xy, u resolution xy. So what this is doing is if we replace this with like, yeah, nothing happens, right? st.x. Oh, it's the location of the pixel. That's what. And then this is a vec2.x equals to the pointer value. No, it's multiply. Sorry, that's multiply equal to. I see a star and I think pointer is multiplied by itself with the x resolution divided by the y resolution. Yeah, so there you go. If you don't account for the x value, it's only the y values that change. So that's where you're getting like only horizontal values, like that's changing. Whereas this actually accounts for everything. Okay, sweet. So we're not gonna do that. What we are gonna do is make the location equal to, can I just do umouse.x? No, it's umouse.xy, right? Yeah, okay. So what's happening now, actually, can we do that again? Yeah, so this umouse, it accounts for your mouse. So something's going on here. Let me think. Vec color. Okay, vec color is always going to be black. So let's just do, well, it will always be black. I just don't want it to be the whole screen. I don't need the whole screen. I do need the resolution. Do I need the whole resolution? Do I care? Because, it's only gonna be, I need a radius is what I need. Vec1, no, is it int radius? Main cannot take any parameters. Fuck! Forgot how to take in an int value. Hold on. Let me just quickly. Not hello world. I'm just going to give an example of accounting for mouse usage here. Or, oh, that's what it is. You have to call the function. Oh, that's right. God, I wish I did this like a month ago when I had this so much more fresh on the brain. Okay, hold on. I know this will work. I just want to see how it accounts for mouse. Well, I know cellular noise will have an example. Okay. So here's your like basic like cellular noise shaper, right? Or shader, right? How does it account for? Okay, so this does change the whole screen. It also grabs the whole resolution here. Okay. It's interesting. Vec color, vec3, 0. That's kind of what we have. Oh, that is what we have. Sweet. So this is just making the variable. It doesn't actually do anything. Cell positions. There's your 0.5. So U mouse divided by U resolution. Ah. Is it really that easy? U time. Vec2 point. U mouse. U resolution. And point has not been made yet. U mouse divided by U resolution. So they're going vec2 is, we'll call it mouse position, is equal to U mouse dot xy divided by U resolution dot xy. No, it's not xy. Sorry, it's just the value. Okay. So instead of the absolute value of this, can I just make it mouse position? Yes. Okay. Okay. Now it's coming back to me. Okay, so now we have color changing based on where your mouse is on the screen. The reason why is because the blue RGB blue value is always shifting from 0 to 1.0 based on where it is on the screen. So you notice how the X value doesn't change anything? I'm sorry. No, yeah, the X value is staying the same, right? It's 0.5 in this case. But when I move horizontally, now the Y value is changing, but the X value, I'm sorry, I am so goddamn dumb. The Y value is staying the same. The X value changes when it's moving horizontally, which gives it that value. Now, I'm gonna guess if I go umouse.y, yeah, now it's the Y value changing, but the X value is the same. Okay, okay, that makes sense. If I go .xy, that should be both, right? No, yes, interesting. Huh. But if I go Y, huh, I wonder why that is. So if I go .xy, that reads the same as if it's just U mouse. Interesting, I didn't know that. Huh, okay. Well, in that case, .xy, .xy. Yeah, this is the same. Okay, I'd rather have it be XY, personally. So, now that we have that established and we have the blue value changing, I don't want to change the color. What I want to do, I need a distance, which is going to be based on the resolution of the screen, divided by some number is our radius. And from that radius, use trigonometry to draw a circle around the mouse. But the color is always going to be black. For now, I kind of just want to keep it at, well, that's a pretty color. We'll just do 1.0, nope, 0.0. I just want to keep it right there because I think that's a cool color. All right, so now that's going to be there. That will just stay there. What we're gonna do is, as we move the mouse around the screen, I want something to follow it, which it can. Let's make a vec. Oh, is this gonna be a vec? Is this gonna be it must be a vec value, right? This circle, or no, it must be an integer, right? Yes, I can use integers. Okay, so what does shaders do? Oh, they use floats. It should be a float, huh? Float because we're talking in the world of 0.0 to 1.0. Minimum distance. So this is gonna be our radius, and that's gonna be equal to 0.1. Actually, we'll make it 0.5. That's half the screen, but that's okay. So we have a radius and a mouse position. Now, I think we have everything we need to just draw a circle on the screen, right? This is gonna be, 0.5 is literally half the screen, but that's okay. So, trying to think about what the easiest way to do this is without totally screwing it up, because we're gonna have to remake some of this when we actually... Let's just draw a circle. Let's not even worry about the mouse position right now. We should just draw a circle. So, at point, center of the screen, we're gonna call it vec2, center point equals u resolution dot x Divided by 2. Fuck. No, that's right. You can divide by 2 here, right? Divided by... No, wait. I'm making this so complicated. Why am I making this complicated? It should just be 0.5, 0.5. What's wrong here? Wait, why can't I do this? Oh, is it no parentheses? Wait, what's the syntax here? Oh. I shouldn't be doing that. God, I should have. Why didn't I do my homework? I did this, I promise you, a month ago. I was a goddamn pro at this, all right? What am I missing? Exponential point power length 2.0. Oh, I see what you're saying. Astrodyne, welcome to the shader. Do you remember how cute we were when we were like, oh, let's make a card game and let's do a little cute little gold border on there. We were like doing pixel by pixel, perfect RGB value stuff. Man, wouldn't it have been easier to just do this? Look at that perfect gradient on the screen. Oh, man. Oh, how dumb we were. Okay. Let's think about this. So from the center, actually 0.5 is dumb. We should just do 0.25. So that way when we draw a circle in the center, all I want is a black circle in the center. That's what we're gonna draw. All right. So what we should do is not worry about this right now. That's what we should do. This should be black, which for now is 0.0, 0.0. I know the color's gone for a second. Don't worry about it. Frag color, that's accurate. But what we need is to define this. So what can I do like if statements in here? I can't, can I? Oh no, I can. There's for loops. If. I'm trying to think about how to do this. If u mouse dot x is less than 0.5, draw this. Else do like 0.5, 0.5, 0.5. So it's gray. There we go. Okay. Interesting how it's not shifting back though. That's not intended. So it's always doing the left one, but umouse.x, what if I just do xy? No, this should be 0.5, 0.5 then, huh? So it's black, but no matter what, it always shifts to that. So that's correct, but I want it to shift back and forth based on where the mouse is. Dum Dum! Hell yeah, we're dumb. Do I even have Dum Dum right now? Hold on. I bet I do. Nope, wait, it's not called that. Wait, is it loading? I have too many assets! Loading, there we go. Beautiful. There we go. Beautiful. All right. How's the stream looking? Looking okay. Okay. So why is this not shifting back? This should be shifting. Oh, wait. See, that works. That's my intended thing. But it's... Okay, but it's only there? Oh, it's literally at 0.00 that it switches back to black and then it's gray. What am I implying here then? What if I just put greater than 0.5? So it's always gray, then it's black. Always. What is causing that? Mouse position. Oh, you know what? I realized this isn't uMouse.x. This is mouse position.x. There we go. That's what I wanted. Oh, God, shaders are complicated. Okay, so what we're doing here, now it finally works. See, there's an invisible line going down the center of the very center of this whole shader, where if it's on the left side, it's black. If it's on the right side, it's a color, which is good because now I can keep track of the mouse easily. Okay, sorry, I was using uMouse.x, not mouse position. The difference being that mouse position is a vec2 where it's the XY value of the mouse divided by the whole resolution of the shader. Whereas before we were just taking the literal X value of the mouse, which is like a number much higher than 1.0, you know? Okay, beautiful. So that's good because now we can do something like, instead of uMousePosition.x, what if it's something like, how do I color it in half? uResolution.x is less than 0.5. Color everything that, else color everything this. So that'll never be below that. How do I make it so I can get half the screen black, half the screen gray? No, we need a better color than the gray. You know what? Let's do, there, we'll do teal. How about that? We'll do black and teal. That's a good Gary color. Do 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 do. Can I get a scalar here? Oh, it's st.y, that's why. There we go. Okay, so that's the color, and I want it to shift to black. Okay, so that is the intended. Now I want to split it in half. So maybe it's while? While that, color that. No, the while's not the correct thing. If is conditional. What do I want here? What do I want here? So what I want, shift color. I want to split it in half where it only renders on the right side. Why am I not thinking of something? So if st dot x. Oh, that is it. Okay, I just did it. Oh, wow. Okay, now I understand. All right. Jesus, that is complicated. Okay, so st.x multiplies by itself the resolution of the screen. Okay, that's what I wanted. Beautiful. So now, or yeah, else color that. Now let's do another one here. Let's do if else. Now I want to cover the bottom of the screen. Else, if else. Oh, is that not supposed to be... Oh, can I not do if else statements in this? Oh, that's cringy. Now we're going to do st.y. Not what I intended. I thought I could get 3/4 of it covered. Why is that an issue? Also, it should be greater than 0.5, right? Because we're going from the top left to the bottom right. Oh, I know what's going on. Oh no, that should be black. If this is true, run this. If this is true, run this. Else, run this. So why is this interesting? So why am I not getting both? That works. Do I have an extra curly brace somewhere or something? No. Oh, I see. Does it not like multiple if statements before the else? Or, oh, I bet I got this else if statement backwards, didn't I? Oh my God, I did. That's what I wanted. Oh! God, programming's hard. All right. Okay. Okay, this is beautiful. It's beautiful because I'm kind of getting it. So now, instead of this elfis crap, what we're gonna say instead, if, now we're gonna include the radius. If st.x is less than the radius, color it black. Or st.y is less than the radius. Okay, now we're getting somewhere. So instead of coloring it this and just calling it a day, we need to qualify these if statements to say, make a circle. Now, trigonometry is not my strong suit, but I think, hold on, paint. Hold on, don't tell me, I know the answer. In a given XY coordinate plane, if I wanted to draw a circle, well, we're gonna imagine that's a perfect circle. Hold on. There. If we wanted to draw a perfect circle, what angle do I need? Don't tell me. This is a right angle, which means this arc, this perimeter, and everything inside of it, which is fine. That's why these black bars are here. Now I know what we're gonna need. So the fill-in's automatic. So all I need to know is the perimeter of like, don't color beyond this. So if it's less than these values. Now if this is 3, we'll say 1 to make it easy, right? And this is -1. This is, in this case, this would be -1. 1. How do I do this? I need this outer perimeter. This is calculus, isn't it? This is like, oh shit. It's like this. It's a for loop. That's what it is. That's what a for loop is. It's a derivative. So if it's a derivative, it's a for loop. Oh shit. Where the base is 0. Oh god, do I need to watch Khan Academy again? Oh god. Don't you do a circle here? Hold on. No, so simpler. There. Oh, it's not a circle, is it? It's just a image. Iterate through the point positions, keep closer distance. Draw point center, step. What is step? Show ISO lines. So without this, this will be a perfect shader. Oh no, it needs that. Absolute value of sine. Oh. Color minus equals the absolute value of sine m distance times 0.07, where distance, or m distance field. Oh. The distance between, oh, it's a keyword. Circle is defined by power length x minus center 2.0. Is it? So this is gonna be a float perimeter equals this, where x is st.x. No, x is the middle of the screen. A disk is defined as power of length x minus center. X minus center is the radius. I still don't understand where the 2.0 comes from. Gonna be totes honest with you. Center is the center of the screen, which is st.x divided by, wait, no. I'm gonna say 0.5. XT minus center? What? Wolfie, hello! Welcome to the shader. The shader stream. It's a little bit boring, but we're learning. So we're gonna say if st.x is less than perimeter. Okay, not quite what I wanted. So that means I did something wrong. Okay. You're squaring the distance? Oh, it's a power. I'm sorry. I see what you're saying. So if this was 3, you'd be cubing it. If it's 4, you're quadding it. Okay, I got you. I didn't understand what the syntax was. Sorry, I'm a C++ nerd. So you are finding the squared value, yeah, of the length of xt dot x, or sorry, st dot xy. There we go. Okay, now we're getting somewhere. So it's not minus 0.5. It's radius. Okay, we're getting somewhere. Not quite there, but we're getting somewhere. Now it should be greater than, huh? Well, no. What am I missing here? We're backwards. I should be coloring the inside. Why did I draw an almond? Okay. So if the given pixel on the screen is less than this perimeter value, which I thought would be inside. Oh, it should be absolute value. No, it's not. Never mind. I thought it was a negative number issue. Huh. Okay. If the given x pixel value is less than... Is this really a float, though? Is that the problem? Well, is this like a vec2 or something, I mean? Because I am using the same value for both. That isn't the perimeter, dumbass? Wait. Is less than distance. Oh. is less than... Oh! If this is less than the distance? The distance being like 0.25 or something. That's your check? No shot. Oh my god. Okay, this should be... Oh! This doesn't do anything. Oh, because I'm checking the same thing twice, like a dumbass. So if this is the defined perimeter, what's wrong here? My center point is not right. In fact, at no point do I ever take in the center point. Except here. What if it's just this? Oh, then it's the very bottom. Oh, so this is 0.5, 0.5, in which case I am subtracting. Oh, there we go. Okay, there's a couple of problems here, but we have what I wanted. Okay, Jesus Christ. That was so complicated, but I get it. I understand. I see the power. Okay. My radius is too large. We should be at the center of the screen. My radius is 0.25. And so that's here. So we're calculating the radius as if it's the diameter. So should it be radius divided by 2? Doesn't work. Oh, sorry, 2.0. Okay, so I should call this diameter then. Okay, gotcha. This is 0.25 now. I wonder why, Oh, I know why. This should be radius. No, that's not. What the fuck? Okay, so that's how we get our arc. Okay. So instead of minus 0.05, I should say something simpler. It should be mouse position. Oh, there we go. Oh, I am God. How is that? All right, now let's do like 0.1. Okay, we're getting closer. Let's do like 0.01. Kind of what I'm wanting. This is across the whole screen though, so. Also, this is in a square aspect ratio. I just have to keep that in mind as well. Because we're not gonna have a square, but we'll ignore that for a second. We'll just have to change this value to be better. What about 0.004? Okay, this is more what I'm wanting. This is good. This is a little too big still. Okay, that's better. All right. Beautiful. And it looks like it's running at, based on my monitor, that's 120 refresh rate. Sorry, 140 refresh rate, and it's lagging. Actually, that's pretty good. I'm betting it's like 30 FPS though, just based on how it's moving. No, that's not right. It is keeping up. This is running at VSync. It's just the shader itself takes that long to update it. Probably because it's being ran online. Okay. So now that's beautiful. So that's kind of what I wanted to accomplish today in terms of like what's going on here. In fact, I kind of like how it lags a bit. It's kind of cute. So we have a couple of things to fix. Why do I have to divide by 2 on the radius? Why does it think this is a diameter? Because it shouldn't be. Like if I do 0.5, the radius should be half the screen. But clearly, Oh, no, that's right. Wait, it fixed. Wait, what the fuck? So 0.25 is a fourth of the screen, so the total circle is half the screen. Oh, no, that's right. Okay. Oh, no, wait, no, it's wrong. I'm sorry. It's divided by 2 still. That shouldn't be there. Yeah, so now this is twice as big as it should be because we're doing the diameter. So this should be half the size. So what am I doing wrong where I'm calculating the radius as if it's the diameter? Is that just the formula we're using, I guess? Well, kinda. Total resolution of the monitor minus the mouse position. That's how we get the point. If the parameter is less than the radius, it's doubled. So why does that? So I have to divide by 2 as if it was the diameter, huh? Okay, well, shit. This is small now. Okay, beautiful. Now, how do we make it where it trails like a little gloop? A little bit of glop, you know? Also, is that still too big? It's hard to tell because of the mouse on there. Kind of want to turn off, Wow, I'm looking at the stream. You guys have it way worse than me. I didn't even notice that. Dude, I'm like moving it around. I just want you to know my mouse and this black circle are perfectly aligned on my monitor. That's weird. You guys got shitty refresh rate on this stream. Holy shit. 30 FPS. Yuck. No, on my monitor, it's like perfectly aligned, the arrow and the circle. That's funny. Also, the circle is still too big, but we'll do it for animation's sake. No, I won't. It's bothering me now. That's better. Okay, that we can see. Okay, so now with this little black circle, what I want is maybe all we need to do is just have a smaller circle. So we draw that, and then we copy, we paste, but we resize everything. So radius is divide equal to 2. What? Assign cannot convert from const int to. Oh. Interesting. It's smaller now. Why? This shouldn't matter. So this is right. But it shrinks. Why? Why does that shrink? Is frag color? Do I need a separate shader? What I was imagining is there would be another circle that's smaller and would just trail behind this one as you drag it around the screen, you know? Do I need a separate shader? Because I think it's like overriding this one. Because the GL frag color is only, we're basically taking a screenshot of the entire screen, right? So if we override this later in this position with this, I guess that means we override it. Unless we just don't do that. Actually, that is probably better, isn't it? So now, if I do this, yeah, okay, I was right. So now this is all right. So now we need to redefine the parameter. Perimeter is equal to this, but instead of divided or to the power of 2, it's to the power of, nope, opposite. It's like 1.8, 1.5. And the mouse position, how do I get it where it was? So this is the only thing that needs to change for it to work. The thing is we can't just have it be where the mouse was. It also needs to like accelerate. Ooh, are we introducing like acceleration and deceleration? Basically, when it's in movement, great. Everything's fine. I guess I could do that first. And then when we stop, it just like collapses in on itself, you know? So what can we do here? How do I record? I guess I could just make a new float value where we just make float. No, it's going to be vec2. Vec2 previous mouse position is equal to mouse position. Okay, that's not right, obviously, but hello there, ad time. Sleepy, hello. I'm not playing ads, so if you're getting ads, I'm sorry. So that's our basic. So how am I going to be logging the mouse position? I guess. Well, how about this? Let's just do this for now. Mouse position dot xy minus 0.1. Now this is previous mouse position. Okay, that's good. So you see that little, hold on, let me make it bigger here. Why is the circle so small? Oh, I know why. There we go. So you see that little extra black circle there? That's our trailing circle, or what will become our trailing circle, right? So let's make that smaller first of all. There we go. So that little less circle there, maybe you could send a uniform from the shader that in the application apply the position and update the application. I mean, that's kind of what I'm thinking, is that we kind of have to, because the variable is going to be, it's like we have to remember a state. And I feel like at that point you're introducing like CPU usage in there, right? Because the GPU doesn't remember where a mouse was in the previous position. It just does. I think it has to be like a separate shader. Like, I think hold on, is that even the case though? Do we really need 3 separate shaders to do one mouse trail? Where if I want a black circle and then I want another smaller black circle after that. Well, yeah, that's the point. No. I don't? But I have to remember the state somewhere. Basically, at this point right here, I need to assign it some flat value that doesn't happen every frame. You could have it in one shader. Well, you probably have everything in one giant shader. I just don't know if it's a good idea. I have no idea if the Book of Shaders editor supports custom data across frames, which is what would be required for a trailing frame. GLSL. Let's see what AI has to say. Let's see if AI is all up to snuff here. Shader, how to remember mouse position. Wow, the AI doesn't even fucking try. How to... Damn. I guess I could click. Does this care about clicking? It must, right? No, it doesn't. Because it's not going to take like an event or anything, right? I don't know what this test thing just did, but I clicked it and now I hate it. Hold on. Okay, there we go. Update on, update off. How would you transfer to CPP within your program? Basically, this would be its own file. I'm not going to do like the C string thing. I can, but I'd rather just have it be its own shader file, and then we'll just import it to C++, and we'll have a shader class that'll handle like storage and everything. So what we're going to do is probably just have a graphics pipeline where I feed the shader. Wait, I don't need to feed the shader anything in this case. It's just always going to follow the mouse no matter what menu it's in. Like even the loading screen. So I would imagine this can just stay forever. But in other cases, it's going to be like, when the note dies, play shader at given XY coordinate, in which case that would be fed information into the shader. But that's not in this case. That doesn't matter here. There must be a way to maintain mouse state. How do I remember the mouse state? I'm trying to think about how to do that in like a real time. God, this is why C++ is the best, dude. Because C++, it's like, oh, do I want something runtime or do I want something at compile time? It's like, in a real time environment, how do you remember this? How do you remember like a state in a real time environment? That's so not what I'm used to. Actually, maybe there's some weird shader here. Shapes, colors, shaping function. Okay, patterns are cool and all, but can I get like a... What does this do? Hold on. Float, shape. No, a for loop's not going to help me. Oh, wait, what about time? Where instead of minus 0.1, could we not do U time? What does that do? What does he do for U time? Times 0.5? I wonder we can, okay, hold on, hear me out. What if we don't need any sort of remembering state? What if we just need to delay the drawn circle by a given amount of time, where it gives the illusion that it's trailing and it's really smart and following your mouse, but in reality, it's just printing a circle and it just stays there. That also solves our problem of acceleration and deceleration, because when we accelerate, it's gonna like stretch it, and when we stop, it'll just stay there. Oh, that's kind of based. But what's wrong here? Can I just subtract by U time? Times 5.0? No, I can't. Actually, no, that's really stupid, because that's the outer position of the thing. Okay, that literally doesn't matter. Except the location of where it is. No, that does matter. You can use a custom buffer or something to store the previous mouse positions, then iterate all over a stored mouse position of the buffer. No, we're not going to do that. I like the idea of just telling the graphics card to just wait. But I don't know much about U time. I wish I knew what the actual value was of it. So float t is equal to U time times 5. Float df is equal to 1.0. Where does he use t? Y plus t. Holy shit. Hex being these values. So that's how these rectangles are flipping because of the time. So if I did U time times 2, yeah, it'd be way slower. And if I did 20 or 30, it'd go way faster. So that's kind of what I'm wanting. U time just tells you how long the program has been running. Really? Does it cycle between 0 and 1.0? Because if I just go U time, it does tick. So there is change. I just don't know how U time, like, ticks, you know? Ugh. Patterns? No, this is nothing to do with time. Man, I've been following you for a while. Yeah, shame we don't have exclamation point follow age. So I do think time has something to do with it, where we're just gonna hold it. So we have the circle only drawn after a given amount of time. Not after a given amount of time. I mean, we're giving the illusion. Oh, maybe not. In fact, I bet if we delete this real quick. That's not what I wanted. In fact, if it's radius divided by U time instead of 2. Nothing. Nice to see you've been growing on the YouTube channel. Well, thank you. I appreciate it. I see you lurking there. So, you guys get what I'm saying, right? Where, like, if I move it to the right, it's gonna trail a circle a distance away from this one, but it's an incrementing value. So, what if we just do mouse position X minus U time? That breaks the whole program. There's a video that might help you here. It might just subtract. I should just do this. Okay. Oh, wait. You know what might help? It's if I actually cheat right. This number minus U time. Hold on. I just want to see. Doesn't do anything. There's a video that might help you here. Yeah, I could watch a video, but am I going to learn anything? Would I, though? I think I learn more if I just experiment like this for a bit more. I think we're on the verge. We're on the precipice. I can feel it. All that needs to change. It can be just an illusion. That's fine. Basically, I need it moved based on some distance off of the radius of the circle. Like that. Basically what it's doing to my mouse right now, but to do it a little bit further away from the mouse. The problem is I don't want to do it with any sort of remembering the previous state. That's why I want this like time thing to work, but I think you're right. Time isn't like a timer. It's just like time from epoch, you know? What if it's the same thing? Previous mouse position. Okay, so what if we just drop this whole previous mouse position thing? And we just say... Okay. And we just say mouse position times equals or something like that. Oh! Okay, we got something going. Okay. Okay, we're getting somewhere here. You guys see what I'm getting at here? Okay. So as we get closer to the corners, it like slowly like gathers, and it does change direction. It's kind of what I'm shooting for. Okay. So we're multiplying. If we divide, it's going to be the opposite, right? Oh, that's just always in the corner. Okay. It's like uniforms are just information sent from the CPU. Uniforms. Ah! Okay, there's U time, yeah. Sine, cosine, a sine, a cosine, a tangent. Power, exponential, logarithm, square root, absolute value, sine, floor, ceiling. This is rounding. Fract, mod, min, max, and clamp. Okay, that's fine. We did that. Yeah, I was hoping when he goes to the application, it just creates two circles and moves it based on the acceleration of the mouse position. I was hoping when he goes to the application, it just creates two circles and moves it based on the acceleration. I don't know if you can get acceleration because there's no state, right? Acceleration is point A, point B. It's distance divided by, or it's distance times time. No, it's distance divided by time is acceleration. And you can't do that without knowing what point A and point B is, which implies there's like two different states. So I'm trying to like give the illusion of movement without necessarily, like right now, this doesn't take into account two different states. It's like one state, but depending on your distance away from something, it like gives the illusion of that. But it's hard to tell. I don't think you can do it without knowing states, right? I don't know if it's possible. It's like we can get close here, sorta. Although, what if I change the power here? No, that's the perimeter of the circle. That's fine. Here. What if we say like minus 0.5? Okay, that is the opposite of what I wanted. Plus 0.5. Okay. Okay. We're getting somewhere. Now, can I clamp it? I can clamp it. So, So this is just the size of the circle, so that never changes. All we care about is the center point, which is mouse position. So can I clamp this all? So can we go like times 0.1? Okay, the opposite of that. Times 3? 0.5? So right now the center of the screen is right bang on. This is fine. How do I get that to... Also, this is really weird. As you go to 0, it coalesces, and then when you move right, it separates, coalesces, then goes off into infinity. So what that tells me is that the second circle, it does have to be based on the mouse. Ugh, I think I have to know states. But how do I know states in a shader without guessing? I think I just have to have it as a parameter, right? I think I just have to feed it the XY value of the mouse. I don't mind doing that. It's not like it's that taxing to get 2 XY values in your program. There are 2 things I'm concerned about though if we do that, and that is, if we do that, then when we do a replay, do I have to record 3 different mouse positions the whole time? I mean, I'm not going to act like that's not just 80 kilobytes, but still. You use a custom uniform. How do I make a custom uniform? I never done that before. GLSL custom uniform. Buffer object. Man, the one time I want the AI to work. I'm trying to like make it generic language. Uniform. Yeah, okay, did we just turn the AI off? Is that what happened, Google? Uniform enum state? What? There are goddamn enums in GLSL? Uniform variables must be defined in GLSL at the global scope. Uniforms can be any type or aggregation of types. All the following are legal. Uniforms are implicitly constant within the shader. Oh, I see. So we're gonna go like, what's the language here? It's just struct, and then we make a uniform of that type. Okay. Struct. Mouse state. And it's going to be int, no, float x, float y, uniform, mouse state, record state. Okay, so no. Record state is equal to mouse position. So that's just work, right? It doesn't. Why? You can't create a uniform within a shader. It must be done in the program. What? I thought you had to declare them in the global scope. It must be defined in GLSL at the global scope. Uniforms are implicitly constant within the shader. They are not constant expressions. Attempting to change them with shader code will result in a compiler error. Similarly, you cannot pass a uniform as an out or in-out parameter to a function. Uniforms are intended to be set by the user from OpenGL rather than within the shader. Fuck! However, you can initialize them to a default value using GLSL initializer syntax. Oh, okay. You can initialize them to a default value using the initializer syntax. This will cause the uniform to have this vector as its value until the user changes it. So what you're telling me is that in order to have a custom uniform in a shader, I have to give it like a C struct, like I'm making like a component to an entity. And when I make it, I then pass it into the shader, which cannot initialize it. Yeah, it's set by the user, and the shader only cares about its final values? Interesting. This does make replays harder though, doesn't it? It makes it harder because if we record the XY position of your mouse for a replay and it's like 120 frames per second, hold on, let's think about this. A uint 16 is like 2 bytes, right? 2 bytes times 2 because we need an X and a Y value times 120 frames a second times, we'll say a 4-minute song, 240 seconds. So that's 115 kilobytes. So in order to do a replay, I need to, assuming I want 3 circles to follow my little mouse here to give it like the illusion of movement, I need to record 3 different mice at any given time in order for the replay to work. So we're already looking at 345 kilobytes, or 1/3 of a megabyte, in a single replay of a 4-minute song just to record your mouse positions, which to be fair is like the majority of the replay value because everything else is real time. The video, this is just recording the actions that the gameplay will kind of simulate, emulate's the better word, right? So if you download somebody's replay, it's 345 kilobytes, 1/3 of a megabyte, just to record their mouse positions. And all of that because I want a stupid shader to work. There's really no way around it, right? You could go smaller. Well, uint 16's already, what, 56,000 something? Well, the problem with a byte is that you're limited to 255, right? So unless we want to, the thing is that if we're gonna do replays of like a rhythm game, the first thing people are gonna use replays for is like, why did I miss that note? So what they're gonna do is they're gonna pause it, they're gonna screenshot this stupid black circle over the note you're supposed to hit, and sure as shit, it's not gonna be on there, or it will be on there, but it's actually incorrect because you divided the screen up into 255 instead of using the actual resolution. And that little pixel that they missed it by, it doesn't look like a pixel to them. It looks like they were on it. And then they get mad at me and then they kill me in real life, okay, with a gun. So you know what? Let's not do that. We have to do uint 16s just for a little bit of accuracy. Although, now that I think about it, actually, no. We don't need to do that. It can be 115,000 bytes, 115 kilobytes. Because if you think about, well, let's think about this, right? So here's what I'm imagining is that while you're playing, it's like, it's going to record it to a text file where it's like, you know, 580, 711, 595, 708, 620, 610. Okay, so this is what's happening, right? As you're playing, every frame, it's going to record an X and a Y value, X and Y value, X and Y value of your mouse, right? So maybe we don't need to record 3 different mice in terms of positions. All we have to do is say, okay, when your mouse position gets to here, if this is your first one, then your second one, then your third one, while you're playing, all this is gonna be, because we need to record it anyway for the replay, what you can do is you can just feed the shader the previous information here and here, and then in the next frame, whatever you do, if it's like 650, 590 or something, then you start here, then feed the shader this one and this one for the trailing circles. So you're not recording more positions, you're just feeding the shader what you already are recording anyway. Okay, that's not bad. I can do that because we have to record the mouse positions anyway in order to get replays work. The replay must store the frame rate too. We must emulate the video at that speed. Oh, well, there you go. There you go. Okay, that's doable. I can do that. That's fine. I was worried about replay file size there, because if it's like, who's gonna download like a megabyte worth of replay, you know? Nobody. But if it's like 20 kilobytes, or in this case, like what? Mouse position is gonna be like 99% of the replay. So it's gonna end up being, well, more like 80%, but it's gonna end up being like 200 kilobytes. 200 kilobytes is fine for a replay, right? Formerly unknown, hello, welcome to the, we're kind of getting circles to work in shaders. It's sort of cool, right? We got it like rotating around a point, kind of like a solar system vibe going. What we're finding out is that we need to maintain a state, which requires integration with the main program. So here's what we're gonna do. Tomorrow, we're gonna add this to the C++ project. We're gonna create a graphics pipeline for SDL3 GPU. Oh, I guess I can show you guys the program. So it's been a few days since you guys have seen this. It's not gonna be impressive, but hear me out for a second. I did a lot on the initialization for like viewport shit, because this is the result. All right, you guys ready for this? Look, I have my arms up like you can see me. Look at how great this is. Oh, the perfect viewport. Look at these solid black bars on the left and right. Look at that solid viewport inside of, oh, it's meant to be, boys and girls. It's meant to be. So tomorrow we're gonna create, I'm basically gonna be using this as like a file. We're gonna integrate with C++. We're gonna create a graphics pipeline, which is like 3 lines of code with SDL3. And then we're gonna try to get it where we actually trail the circle based on states that we're gonna feed the shader. So that's gonna be like a 90-minute project tomorrow. Instead, at whatever the refresh rate is set at, actually it must store the screen resolution too. The screen resolutions, that's trivial. We already, hold on, let me show you something cool. So when it comes to the resolution of the game, there's nothing hard-coded. This config file is old code. We don't actually do that anymore. Instead, what we do, look at this. SDL display ID, monitor ID, get displays. So what this will do is no matter how many displays you have, 0 should be your primary display. Then we're gonna make a display mode, monitor info. Basically, I'm gonna grab your monitor's primary info and create, and this is like a struct containing all of it. This is stuff like refresh rate, resolution, all that shit, all that information about your monitor. I think you can even get like a description. Then you, actually, hold on, let me check that. That's a good question. Search online. What's in this? Width, height, pixel density, refresh rate numerator, refresh rate denominator, internal data, which is private. Okay, cool. Then we have our viewport aspect ratio, which is 16:9. So no matter what, it's a 16:9 game. Then we calculate, meaning that if you have a weird shaped monitor, you have black bars either on the top or the bottom or the left or the right, which in my case, because I have a super ultra wide, this is a 16:9 aspect ratio. So this is the difference between a 16:9 aspect ratio and my total like resolution of my monitor, to give you guys an idea of how wide my monitor is. So that's kind of what's going on there. I hope you guys can actually see the blue. Wait, Could you guys actually see the blue? Oh, wait, hold on. Let me boot it up on my phone. I can see. I don't know if you guys can actually see this blue or not. Gary the Goo Boy. Hold on, there's a commercial. Okay, you see blue. Okay, based. Based. Okay, so all that is to say, we actually keep the resolution and viewport inside of the settings on the program. So theoretically, because everything is based on the viewport, which is always 16:9, there's not going to be any sort of flat numbers in regards to resolution. It's all going to be relative to the viewport of whatever your installed program is, of your installed resolution. So it's resolution neutral. Is that the right word? It's like, it's resolution independent. It's going to be all relative to the viewport. All right. Well, at least that's the theoretical idea. Well, that's what we accomplished today. We made a cool little thing. We learned a lot about states and custom uniforms in shaders. Tomorrow, we're going to put our knowledge to the test, and hopefully we're going to be a lot more productive than today, because a lot of this was remembering how shaders worked, but we got an idea. Does it map to doubles? Does it map to doubles? What does that mean? I'm sure you mean like double, like float doubles? No. It's all integer based. Anyway, have a good night. Have a good evening. I'll see you guys tomorrow. We're going to have a grand old time. I'll see you. We're going to do more shaders. See you. Goodbye. Wink.